Hello students, we are starting this course of Green Technology with this introductory lecture. We'll start with the basic concepts and introduction to green technology and then gradually and systematically try to build the basic concepts of green technology and try to learn about different green technologies. So, let us begin. Green technology is a relatively new term, having been adopted just over last couple of decades. Today, green technology is the way to go. In order to understand what is green technology, let us start with a simple definition of green technology. Green technology means the technology which is environmentally friendly, developed and used in such a way so that it does not disturb our environment and conserve natural resources. You may also have heard about green technology being referred to as environmental technology and also as clean technology. Unlike the technological waves in recent decades, green technology is almost material science based, relying on the availability of alternative sources of energy. The purpose of this technology is to reduce global warming as well as the greenhouse effect. Its main objective is to find the ways to create new technologies in such a way that they do not damage or deplete the planet's natural resources. It also expresses less harm to human, animal, and plant health. With the help of green technology, one can reduce pollution and improve the cleanliness as well. Today, developed as well as developing countries are turning to green technology to secure the environment from negative impacts. By adopting green technology wisely, the earth can be protected against the environmental pollution and other various harmful things. Now we have to understand what is the importance of green technology in today's world. Using green technology has become important today. It is important to stay current with what's happening around the world. Today's technology and conveniences are more focused on making luxuries available to more people. The ugly side of this is the harm that these products or new technologies are doing to our environment. This raises the importance of using green technology all the more. For using green technology, industries and regulatory bodies are already taking steps in the right direction. By using green technology, one can make the effort to help the environment heal. Developing a plant community, making less packaging materials, using environmental friendly machines are just few examples. Using green technology will become not only important but mandatory too in coming years. With the Earth's energy resources depleting fast, we have to rely on alternative sources of energy. Green technology encourages the concept of cleanliness, freshness, as well as promotes new dimensions. Now, after understanding the importance of green technology, now we have to understand how green technology has been adapted in the industry. Several developed countries all across the world are already encouraging the green technology in industry. Billions are being invested in new wind projects and biomass plants. State-owned enterprise and private sectors are motivated to develop the green technology industry. For example, wind turbine manufacturers and wind developers are already using green technology in industry, such as in countries like US, China, and parts of Europe. Solar power industry is growing at an astonishing speed and aims to achieve enough solar capacity and use green technology in industry. There is another example where you can see green technology has been adapted, and that is green computing, referring to environmentally sustainable computing. Today, focus is shifting to designing, manufacturing, using and disposing of computers and other related devices efficiently and effectively, with minimal or no impact on the environment. More attention is being given to recyclable and biodegradability of obsolete products and industrial wastes. Using green technology in industry is on the rise as consumers around the world, as well as many car manufacturers, are actively involved in developing green technology that can be applied to their products. Green technology in industry will influence a lot on the development, as almost everyone seems to realize the harmful effects of greenhouse gases and global warming on the environment. Now, after this, we need to see what are the major goals of green technology that it has intended to achieve. First is sustainability. What is sustainability? It means meeting the needs of society in a way that can continue indefinitely into future without damaging or depleting natural resources. In short, meeting present needs without compromising the ability of future generations to meet their own needs. Another major goal is cradle to cradle design. The major, what you call as the impact of green technology, will be ending the cradle to grave cycle of manufacturing of products by creating products that can be fully reclaimed or reused. Another goal is that of source reduction, reducing the waste and pollution by changing the patterns of production and consumption. Another goal is innovation, that is, developing alternative technologies where the fossil fuel or chemical intensive agriculture that have been demonstrated to damage health and environment. Another goal is that of viability. That means creating a center of economic activity around technologies and products that benefit the environment, speeding their implementation and creating new careers that truly protect the planet. Being a computer science student, I'm sure you must be wondering, where does the computer science or computers actually fit into green technology? Several recent developments coming from the high-tech sector are the result of the anxiety revolving around the green technology and making environmentally friendly machines. As you know, computers are hard to recycle and are rarely recycled, as today's computers are made with considerable amount of lead, cadmium, brominated fire retardants, and plastics that can lead to toxic breakdown products. Green computers or green computing refers to encouraging environmentally sustainable computing. It involves the practice of designing, manufacturing, using, and disposing computers and associated subsystems effectively and efficiently with almost no impact on the environment. Research is still going on into the key areas in making green computers into as energy efficient as possible. Efficient computer technologies are being developed to promote them as environmentally friendly machines. Computers and related equipments have been charged for much of the global warming as among other reasons. Sophisticated, power-saver and hibernation modes and laptops just take minute nips in the energy rather than guzzling from the plug. The extensive adoption of liquid crystal displays has given way to substantial savings over less efficient cathode ray tube technology. Green computers promise to be completely carbon neutral in coming years, which means reduced emissions. Ideas of solar-powered workstations are already floating, which will cut down on annual electricity costs through more energy-efficient equipment and operations. The fast-paced technological world of today sure has a green lining. Not only will these environmentally friendly machines save everyone's money, but they will go a long way to protecting our precious planet. So, till now we studied about the basic definition and introduction to green technology. Then we studied how green technology has been adapted in the current industry. And then we studied something about the goals and then the green computers. Now we have to take up each of the green technology and the concepts of green technology in detail. We'll first take up the wind energy that is called as the pure green technology. Why is it called? We'll study that, and we'll start with the basic concept about wind. What is wind? Wind is atmospheric air in motion. These are caused by the solar energy, but these are not the direct form of solar energy. It's actually an indirect form. Why is it indirect form of solar energy? Because they are created by sun's uneven heating of the atmosphere, and not just by the uneven heating of the environment, but by the irregular surface of earth and the earth's rotation also. That also plays a part in the creation of winds. So this wind flows, and this motion of the wind is harvested by the modern wind turbine, which is used to make electricity. How does wind turbine convert this energy in the winds into electricity? The wind turbine converts the kinetic energy in the winds into mechanical power, because the rotation of the turbine is actually a mechanical power. This mechanical power can be used for specific tasks. For example, there are simple tasks like grinding of grains, pumping of water, or a generator can convert this mechanical power into electricity to power homes, businesses, schools, etc. The force of the wind that makes this turbine blade spin, that is, it converts the kinetic energy of the wind into the mechanical power by turning the blades, and this energy is tapped, or you can say harvested, and then with the help of a generator it's converted into electricity. Now this wind power or wind energy, it describes the process by which the wind is used to generate mechanical power or electricity. For large scale production, what is a wind farm? First, I will try to explain that. Wind farm is a large land in which there are many wind turbines installed, and it's called as wind farm. And wind farm is used for large scale production of electricity, because when there are so many wind turbines, the whole output of these wind turbines is collected and it's coupled together to get electricity on a commercial scale. Okay? Scientific principles of wind. Now we have to understand what are the scientific principles that govern the whole idea of converting the wind's energy into electricity. First principle is that of Newton's first law and rotational inertia. So how is it used? Mass in motion tends to stay in motion, or mass at rest tends to stay at rest. That is, if an object is moving at a constant velocity or is stationary, then the net force acting on it must be equal to zero or balanced. The blades have rotational inertia proportional to their mass and how the mass is distributed radially from the hub axis. Now, how is it applied on this wind? A low rotational inertia is desirable while maintaining the strength. A low rotational inertia is desirable while maintaining the strength so that the turbine can accelerate from rest in light winds, or quickly increase its rotational rate when the wind speed increases, optimizing its power output. Modern wind turbine blades are often made from aluminum and carbon fiber. Why is it made from aluminum and carbon fiber? Because they are very light. Carbon fiber, because they are very light. Okay. The second principle that applies is Newton's second law and Saugne's impulse wind turbines. What is the theory behind it? A change in velocity, that is speed or direction, is acceleration. Acceleration indicates that an unbalanced force must be acting on the mass. Rearranging tells us that the change in momentum is equal to impulse force. And what does that mean in terms of wind turbine? That is, wind turbines pick up some of their kinetic energy from the deflection of the air as it hits its blade. Air blowing onto the turbine blades is forced to change its velocity at constant pressure. A change in velocity creates a change in momentum of the air mass, which indicates that the force must be acting, that is Newton's second law. This rotation arises from fluid deflection, is a feature of impulse turbines. Wind turbines also have features of reaction turbines. Now we have in the further slides we'll see what's Bernoulli's principle and Newton's. Third law, which will apply on this wind turbines. Okay. Another principle is that of Newton's third law and reaction turbines. What's the theory behind it? That is, for every force that acts on the object, there is an equal and opposite force or reaction force exerted by that object. And its application on the wind turbine is, this is the principle behind the reaction turbine. Air moving over the blades changes its local pressure due to Bernoulli's effect. The difference in pressure between the top and the bottom of the blade creates a tangential force over the blade area known as lift. The lift force acting tangentially at a distance from the hub creates torque, thus rotating the turbine. The blade pushes down on the air and the air pushes up on the blade, creating a lift. The blade is reacting to the difference in the air pressure. You can actually imagine it as a rotation of a fan. How the blades are moving and how the air is helping it to rotate actually. Another principle, or you can say equation, is the Betz limit. The theory behind the Betz limit is the equation is derived from several laws, including conservation of momentum, conservation of mass, and Bernoulli's principle. Betz's law places an upper limit on how much energy can be extracted from moving air. It also predicts that the amount of energy able to be collected from the wind is directly proportional to the collecting area of the rotor disc, as well as the cube of the wind speed. Now, how this principle is applied on the actual wind energy is, if the wind speed doubles its power, it's increased 8 times. If the rotor diameter doubles, it collects 4 times the power. The Betz equation predicts that no more than 16 by 27 or about 59% of the inherent energy in the wind can be converted into mechanical energy at the rotor. In practice, modern wind turbines convert up to 80% of the Betz limit power into electricity. Another principle is that of power and wake rotation. What's the theory behind it? Work done is force times distance moved. Power is work done in a unit of time. Power is therefore force times velocity. Rotational power is torque times angular velocity. This means if torque decreases and rotational speed of the blade increases, then the power can remain constant. Now, how is it applied on the actual wind energy? Is that when the wind creates a torque on the turbine must also place an equal and opposite torque on the wind. That's Newton's third law, thus causing the air to accelerate tangentially as it passes through the turbine. This wake rotation removes energy from the turbine. To minimize energy losses from the wake rotation, it's desirable to decrease the torque of some optimal value. So if the rotational speed of the turbine is increased, then torque is decreased and the optimal power is extracted from the wind. The optimal speed is determined by the ratio of the wind speed to the tip speed of the blades, ideally around 5 to 7 for utility scale turbines. Another principle is that of Bernoulli's principle and lift generation. So what's the theory behind it? Energy in a given volume of air moving through the swept area of the turbine is due to its pressure and its velocity. Along a given streamline, that is flow path, the sum of these quantities must remain constant. Now we have to understand how is it applied to the wind energy. At the blade scale, one result of Bernoulli's principle is that when the velocity of the flow increases, such as when it moves over the more cambered side of the aerofoil blade, then the pressure of the air must decrease. This leads to lift force on the blades. On the whole rotor scale, pressure is increased in front of the rotor and decreased behind. It results in energy extraction. This change in pressure is the feature of reaction turbines. Now, after studying all the scientific principles that govern the working of the windmill, we actually, in a simple terms, try to understand how the windmill works. When the blowing wind strikes across the blade of the windmill, it exerts a force on them, due to which the blades of the windmill starts rotating. This in turn rotates the shaft of the turbine and generates electricity. The electricity is sent to users through a transmission system that consists of electric transmission lines, towers, substations, and other components. One of the challenges of the transmission of electricity from wind energy is that the winds are intermittent. That is, it comes and goes. Winds cannot be stored for future use. Small amounts of wind-generated electricity can be stored using batteries. However, intermittency does create concerns for stability and reliability of utility-scale wind energy generation. What does this mean, utility scale? Large scale wind energy generation. The integration of wind energy into a transmission system requires careful engineering to properly condition the power generated and carefully planning to balance the mix of wind energy with the other sources of energy. Now, the machines that generate the electricity are the most conventional type with airfoil propellers employing 2 to 3 tapered blades. The electricity can be produced by rotating an armature in between the poles of the strong magnet. The shaft of the armature of the generator is connected to the wind turbine by a connecting rod. When the wind rotates the blades of the wind turbine, the shaft rotates, and this in turn rotates the armature, thereby producing electricity. So this is the whole idea behind how this wind turbine works, or you can say the windmill works. As you can see clearly in this figure, what I explained earlier, how this wind actually strikes on the wind turbine, which in turn moves the shaft, and there is a small electric generator which generates electricity. This is the working of a windmill. After understanding all the concepts about the wind, how it's harvested, how the energy is converted into electrical energy, now we have to see what are the advantages and disadvantages of actually using the wind, as the whole concept of using wind energy is actually using it as a green technology. So the first advantage of the wind energy is purely green. So wind energy, as you can say in other words, wind energy can be as green as it can be. There are no forms of energy that are truly green, while solar, wind and hydroelectric power produce no emissions. Once the facility are placed, the production and installation of those facilities comes with their own set of costs. However, the environmental cost of building and operating wind turbines is a fraction of the cost of any other traditional means of power generation. While coal and oil-fired power stations continue to pump out emissions throughout their lifetimes, once wind turbines have been installed, their ongoing carbon footprint drops to zero. In fact, a modern wind turbine will reach its break-even point just 8 months after installation. This means that a turbine will produce enough clean power in 8 months to counteract the carbon footprint of its construction. That's great, no? So the second advantage is free power forever. What does that mean? An even more compelling case for wind power is that once the turbine has been built and installed, a wind farm will produce energy at essentially zero cost as long as it's properly maintained. No fuels need to be mined, transported and burned, with minimal cost for staffing and maintenance. Beyond these costs, a turbine will generate energy that becomes cheaper and cheaper with each watt produced. So the third great advantage is wind power can go anywhere. While some locations will offer great efficiency than other based on the local wind patterns, one of the major advantages of wind turbine is that they can be installed anywhere wind currents are present. We could fill deserts, countryside, and even oceans with country turbines to take advantage of the potential global wind energy. Wind power isn't limited to sprawling wind farms either. All of us can install wind turbines in our homes to supplement our energy needs. At a relatively low cost, we could increase the wind power production to many times its current capacity. As you know, everything has its pros and cons. So tapping of the wind energy also has its disadvantages. So the first disadvantage is that it's a threat to wildlife. In early days of wind power, there was great concern about the effect of wind farms on wildlife, especially birds. Birds made a habit of colliding with the blades of turbines, and many even built their nests in the structures themselves. While bird strikes is still a problem for wind farms, it's not nearly as severe as it was in the past. Modern turbines operate at a higher efficiency than the earlier models, providing the same power while blades spin at much lower RPM. Towers have also been redesigned to prevent birds from nesting. This concern, then, is a more of a design challenge than an intractable problem. With the right design, the effect of the local wildlife can be kept to a minimum. Furthermore, it's worth remembering that most other forms of energy production have a much greater impact on wildlife, and even power lines are more dangerous for bird life than wind farms. Another disadvantage is that of predicting power from wind turbines. One of the major problems with wind power is unpredictable nature of raw material, which in this case is wind. While traditional power stations can control their production at will, wind turbines depend on the local air currents to keep production continuous. When the air is still, blades do not turn and the power production drops to zero. To solve this problem, we must locate our wind farms in areas with strong, dependable air currents that rarely fluctuate. Offshore locations usually provide strong winds, as do hilltops and other exposed areas. As long as we never reach the point at which we depend entirely on a constant airflow to maintain our power requirements, this needn't be a serious problem. Another disadvantage is that wind farms are an eyesore. One of the most bizarre complaints is that wind turbines are unattractive and spoil the landscape. This is understandable complaint, but it seems odd to complain about a wind farm when we have for so many years erected endless pylons and power lines across even our most beautiful landscapes. This is a problem that should be resolved itself on its own. In time, people will become accustomed to the sight of wind turbines, and they will be ignored just as we ignore power lines. The only alternative, it seems, would be to locate our wind farms far from the human habitation, which would cause more problems than it solves. Another issue is the cost issue. Even though the cost of wind power has decreased dramatically in the past 10 years, the technology requires a higher initial investment than fossil fuel generators. Roughly 80% of the cost is the machinery, with the balance being site preparation and installation. If wind generating systems are compared with fossil fuel systems on a life cycle cost basis, however, the wind costs are much more compensative with other generating technologies because there is no fuel to purchase and minimal operating expenses. Another disadvantage is that of supply and transport issues. The major challenge to use wind as a source of power is that it's intermittent and does not always blow when electricity is needed. Wind cannot be stored, and not all winds can be harnessed to meet the timing of electricity demands. Further, good wind sites are often located in remote locations far from the areas of electric power demand, such as cities. Finally, wind resource development may compete with other uses of the land, and those alternative uses may be more highly valued than electricity generation. However, wind turbines can be located on land that is also used for grazing or even farming. While wind power isn't an ideal solution to our energy needs, the pros are far outweigh the cons. An endless supply of clean, renewable energy that can be produced cheaply and easily is the holy grail of energy production. Wind power can provide it so long as we can learn to accept the few small disadvantages that come with this such an abundant supply of power. And don't forget, it is a green technology. At the end of this lecture, you should be able to answer following questions. What is green technology? What's the need of green technology? Importance of green technology in today's world. Goals of green technology. What are the green computers? Wind energy. What are the basic concepts of wind energy? Scientific principles governing wind energy. What are the advantages and disadvantages of wind energy? This was the first lecture. I hope you understood it. So if anybody has any queries, they can email me on following email address. Thank you.